Hi. So this is my answer to the questions on your platform. So I'm going to face the camera on my paper down here. I hope you see. All right. So the first question says, why is that H2PO4 acts as an acid and a base? So basically, H2PO4 minus is said to be amphoteric, which means it can behave like an acid and a base. It's said to be amphoteric. So as a base, it accepts a proton in the form of hydrogen ion. As an acid, it will donate a proton in the form of a hydrogen ion in equilibrium. So let's take a look at that. In equilibrium 2, it acts as an acid. So as an acid, it will donate a proton in form of hydrogen ion and leaving us with, sorry, this is just minus 1. So the HPl4 donates hydrogen ion becomes HpO4 2 minus. Here it acts as an acid because it has donated a proton. An acid is a substance that donates a proton. So this definition of acid is based on the Bronsted-Lowry theory, which defines a substance that acts as a proton donor to be an acid. And by that we mean donating hydrogen. That's what we mean by proton donor. In equation 1, it acts as a base because there it accepts a proton. H2PO4 minus will accept hydrogen ion non-equilibrium, thereby acting as a base to give us H2PO4. So when H2PO4 minus accepts a proton in form of hydrogen ion, it will form H3PO4. So the minus goes away, leaving it with nothing there. So here it acts as a base. This is still based on the Bronsted-Lowry theory in terms of how we define an acid and a base. So I hope this answers question 1. So as an acid, it will donate a proton to form HpO4 2 minus. As a base, it will accept a proton to form H3PO4. So I hope that answers number 1. So let's go to the next question. Question 4A2 is asking us to draw the structure of H3PO3. The structure of H3PO3 look like this, with a P bonded to the O and H and OH and H2O. So all the 3 oxygen atoms are single bonded to phosphorus. And that's what you have it. All the 3 oxygen atoms are single bonded to phosphorus, and each oxygen is bonded to hydrogen. So bond angles for the O to P to O, I hope you can see, is equivalent to 107 degrees, and bond angles of P to O to H, is equivalent to 104 degrees, 4.5 degrees, sorry. So those are the bond angles for each of them. So bond angles for OPO is 107, and bond angles for P to O to H is 104.5 degrees. So we'll look at the next question, which is question 4A3. Question 4A3 is asking us to give the name of H3PO3. H3PO3 is called phosphoric 3 acid, and we do that by calculating the oxidation state of phosphorus there, which is 3 plus X minus 6 equals 0. Sorry. Minus 6 equals 0, and then finishing the mathematics equals 3 plus X equals 6, X equals 6 minus 3, X equals 3 plus. So that's why it's phosphorus 3 acid. Okay, so that's question 4A number 3. And so we'll go to the next question. Alright, so next question says that phosphine is a poisonous gas, and phosphine reacts with oxygen gas to form phosphorus 5 oxide and water. So we're going to take that. So phosphine is pH 3, reacts with oxygen gas, O2, to form phosphorus 5 oxide. That should be P4O10 plus H2O. P4O10 here, that's phosphorus. So if you calculate the oxidation number, that will be 4x plus 10 equals 0. Phosphorus 5 oxide and water. So we need to balance the equation, obviously. So this is what we get, but the equation is not balanced. So we need to balance the equation. So in balancing the equation, we're going to run through it. I like to take my time to balance. I'm going to write out P, H, O on the left hand side, and on the right hand side I have P, H, O. So P, this is it. So we balance it step by step. P is so altogether a balanced equation will give us P is 1 here, H is 3 here, O is 2 here, P is 4 here, H is 2 here, first O is 10 and the second O is 1. So all together in balancing we're going to have, put a 4 here, make this one 4, put so P is balanced. You put 8 here for this, it makes it 16. So we'll have to find a way to make this 16. And one way to do that is to add 6 here. Add 6, the other one becomes 6. right, becomes 6. And hydrogen is 3, 2. But hydrogen here is now 12, and it's 12, so it's easy. So this is times 6, 12. This is times 4, 12. So that's our balanced equation. 4 moles of phosphine reacting with 8 moles of oxygen gas and giving us 1 mole of our product and 6 moles of water. Hope that makes sense. And that's our balanced equation. We can also reduce it or making it a multiple of 2 by dividing all the equations by 2, by 2, by 2, by 2. When we do that, our final equation will be 2pH3 plus 4O2, giving us products P2O5 plus 3H2O. So this should be our final equation. If that makes sense. Alright. So that answers that. On to the next question. The question says aqueous silver nitrate, AgNO3, is reduced by pH 3. The unbalanced equation is shown below. We're asked to balance the equation and use oxidation numbers to explain why this equation is a redox reaction. So I'm going to write it out. AgNO3 plus pH3 plus H2O, giving us solid Ag plus AgNO plus H3PO3 plus HNO3. So this is what our equation looks like. So in balancing this equation, we will find a way around it. In balancing this, we're going to have 6 AgNO3, it's 1 pH3, 6 Ag, 1 H3PO4, and 6 HNO3. From the equation, you see that Ag is reduced from +1 to 0. Reduction is defined as how do I put it? The reduction is when the oxidation number decreases. So from +1 to 0 is a decrease, so that's reduction. And then P is oxidized because the oxidation number increased from -3 to +3. So this explains that equation. I hope this helps. I'll try to write as much as I can. Thank you.